Okay, the first energy resource we're going to look at is fossil fuels. Now that can be coal, oil or gas, but they all work in exactly the same way. So we burn the fuel in some sort of furnace, the chemical energy is turned into thermal or heat energy. That heats water, turns it into steam. The steam turns the turbine, which turns the generator, which generates electricity. Now, almost all our energy resources will finish with that statement. Something turns the turbine, which turns the generator, which generates electricity. The only difference is what we use to turn that generator. Now, based on that, let's look at our little table of all our energy resources. And we'll go through our 3 R's, first of all, for our fossil fuels. Are they renewable? No. It takes millions of years for coal to form, so therefore it can't be replenished in a human lifetime. Is it reliable? Yes, at 9 p.m. tonight we can definitely burn coal to produce electricity. Can it respond to changes in demand? Yes, we can burn more fuel, that will produce more steam, which will turn the generator faster, which will generate more electricity. Does it produce CO2? Yes. So fossil fuels will lead to global warming, which is a negative. Other things we can put in, it also will lead to acid rain. We could also start talking about finances and things like that. Fossil fuel power plants have been built for a long time, so they're relatively cheap to build, but we have to pay for the fuel, which does make the cost maybe about medium to run. The next one we're going to look at is nuclear. Now, nuclear is almost identical to our fossil fuel power plant. The only difference is, rather than burning coal in our furnace, we use uranium fuel rods, and they undergo fission. So we put fuel rods in here, and they provide the heat through a nuclear reaction. So we split the uranium nucleus. That does lead to some differences. However, they will still not be renewable, because uranium is formed in stars when they die at the end of their lives. All the uranium that's in Earth is all we have. We're not making any more, so it's not renewable. Is it reliable? Yep, we can definitely produce electricity using nuclear power tonight at 9 p.m. Can it respond to changes in demand? Yes, we can lift the control rods and make the uranium fuel undergo more fission reactions per second, which will generate more heat, which will turn the generator faster and produce more electricity. Does it produce CO2? No. We're not burning anything. There's no combustion in a nuclear reaction, therefore we're not producing carbon dioxide that leads to global warming. Now, there are some major others for nuclear energy. One of the things is there's a small chance of a radioactive leak or a meltdown, which can lead to radioactive substances being released into the environment. They are also difficult and expensive to decommission. I can barely fit that in there. By that, what we mean is, at the end of a fossil fuel power plant's life, we can just knock it down and reuse that land. You can't do that with a nuclear power plant. You have to take it apart bit by bit. You need very specialized personnel to do that, and you'll have to store any of the radioactive material for a very, very long time. That whole process makes it expensive. The other negative of this, although the fission of the uranium fuel rods does not produce carbon dioxide, it does produce radioactive waste. And that waste will stay radioactive for tens of thousands of years, so we need to store it in specialized facilities for a very long period of time, and that makes nuclear energy expensive.